What's up, guys? Welcome, welcome, welcome. Alrighty. So, today, what we're going to be doing is we're doing a little bit of experimentation. This is going to be a little R&D type of a stream. One of the things I'm working on right now is a flex cable, okay? And I haven't gotten very far into the design of the flex cable. We're more in the figuring out whether or not this is going to even work stage right now. But on the PS2 Slim, as some of you might know, the early revisions, the V12 motherboards, had the components, like the pins that are required to connect an IDE hard drive, just like on the fat model PS2s. The pins are in here. Even though there's no connector for a hard drive, the pins are in here. And there have been various mods over the years that would solder to these pins and reconstitute an IDE cable and allow you to connect a hard drive, usually externally. And that would allow you to use like OPL, for example, to load PS2 games off of a hard drive on a PS2 Slim. And then recently, people have started using these SD card to IDE adapters. There's like StarTech, I think, is the company that makes the ones that most people use. And those are great because you can use an SD card. You can mount it inside of the console shell, so you don't have an external drive. The SD card adapter mounts, somewhere in this area here on the bottom of the motherboard, which is neat. But the issue with that particular adapter is that it has a limitation. It can only do a maximum of a 128 gigabyte SD card, which is a big problem because that's not much space for the PS2 library. But there is a company that makes these little SD card adapters called iFlashes. And what these are actually designed for iPods. You're supposed to take your hard drive out of an old classic iPod and install one of these instead, and this adapts an SD card to it so that you can have larger capacity drives inside of these old iPods, and they use less power as well. So the iFlash chip here converts an SD card into an IDE like signals for the iPods, because those all used 1.8 inch IDE drives. But it comes in the form of this flexible ribbon cable connector. And essentially what I want to do is I want to design a flex cable that installs onto the motherboard, and then somewhere on this motherboard, I haven't figured out the exact best mounting yet, but somewhere on this motherboard the iFlash will sit, and then the flex cable will come down and plug in so that you don't have to manually solder all of the pins individually. You can just install the flex cable and then plug it into the iFlash, and then there you go. You've got an SD card based solution for the hard drive in a Slim PS2 that doesn't have the 128 gig limit. So the flex cable has not been designed yet. I know what needs to be done with the flex cable design. It's just a matter of actually making sure that all the wiring, my pinout and everything is correct, because I've got a pinout for these 1.8 inch ZIF connectors, and that's what this stream is for today. I'm going to manually wire up this adapter board, this flex cable to 40 pin adapter board, and verify that my pinout is correct. And assuming that my pinout is correct and this iFlash works, then I can move on to creating the flex cable design. So we're going to solder up this adapter and test it out, and we'll see what happens. Real quick, I need to pull up my pin out. All right. Okay, I think I've got everything organized. Hello, Conquer 19 to 21. How's it going? All right, so I've got my pin out pulled up on my computer screen. Let's zoom in. We're gonna take a look at the area we're gonna be working in. All right, so the main area of interest is this area right here. There's several different pins we need to solder to there. And then on the other side of the motherboard, this area right here. We've got a few different things we need to solder here as well. Now, this motherboard, ignore this wire. Just forget about this wire. This is a damaged, this motherboard has some damage. The lid switch is gone off of this one. So years ago, I had to bodge in this wire to fix this lid switch issue because it got ripped off somehow. And I pulled this out of my junk bin. It's a working PS2, but it's kind of like a junk. It's kind of a junky PS2. So it's going to be a good test bed for us today. But anyway, that wire has nothing to do with the mod we're installing. It's just fixing a previous issue. All right. Give me 1 second. I'm going to run over to my other computer and get the SD card that I prepared with the game ROMs. And that way we'll be able to test quickly once I get everything soldered up. I'll be right back. Never mind. Never mind. The SD card, the ROMs are not done transferring to it, so it's still going. So we'll check in on that later. All right, so let's go ahead and get started. We're going to be soldering some wires into this adapter. So I'm going to go ahead and get this adapter positioned where I want it for the soldering process. I'll just stick it down with some tape. All right, I think this should be a pretty good location for it. While we're working. This is not permanent, of course. This is just for during the soldering process to keep everything neat. So this flex cable adapter will just plug into our iFlash board here, and then we're just going to manually wire up all of the pins from here to the locations they're supposed to go on the board. And today I'm trying out some new Kiner wire that was recommended by Nostalgic Indulgences on Twitter. It's like a off-brand Kiner wire. It's supposed to be really nice though. Alright, so let's go ahead and get started by zooming in here to this area that we're going to be working on. This little resistor array right here, we're going to be soldering to each of the 4 points here on the bottom of this array. Let's see. Okay, so that looks pretty good. All right, let's go ahead and tin this up. Hit it with a little bit of flux, and we'll go ahead and bring a wire in here. Get our first one done. Okay, that's the first one. And that's supposed to go to pad 18. So we'll just bring it over here. I'm going to leave a little bit of slack in this. This is not going to be super tight because, like I said, this is just for testing purposes. And whenever I design the flex cable, I'm going to be stripping this back out of here and installing the flex prototypes once I get them. This new Kiner wire is pretty nice. It's a good recommendation. The jacketing material is pretty heat resistant. The biggest issue I've had with the previous like off-brand Kiner wire that I've used is that the jacketing is so so fragile, so weak to heat that it just melts. Like if you just look at it. Conquer, I'm using 30 gauge wire on this for the test. Not sure if that's a good idea or not. I've never done one of these SD card hard drive mods, but seems like that's probably what most people who are doing them are using. So I think it'll probably be fine. Okay, next pin here. Oh, got a bit of a bridge there. We'll clean that up. There we go. All right, and this is supposed to go to... Oh. I made a mistake. Already. First wire I soldered was a mistake. This wire, this first wire on this array, the one to the furthest to the left that I did first, it's actually supposed to go to pin 20. And the one that I'm soldering, that I was working on just now, is supposed to go to pin 18. So, no big deal. Alright, so this new wire comes in and goes to pin 18 now. Oh, Matt, yeah, so the plan is to relocate the SD card slot, like as part of the mod, to relocate the SD card slot to another, to like the front of the PS2, kind of like how the other SD card mods for PS2 Slim are normally done, the StarTech mods. There's like a grill, there's like a vent on the front that is like the perfect size for a micro SD card. So just relocate a micro SD card reader to the front and you'll be in business, I think. That's the idea, at least. All right. Okay, the next pin to the right on this resistor array is going to pin 14. So let's go ahead and get that prepped up. Oh, got another bridge. This one might be kind of challenging to clear, to be honest with you. There we go. I don't use the J-tip often, but sometimes it is nice. Okay, so this should be going to pin 14. Pin 14. Oh, weird. These wires fuse together. I guess they got hot enough that the insulation didn't melt all the way, but it fused. One fused to the other. Okay, that's something to keep in mind with these, with this new wire. I do like it so far. It's pretty nice compared to the typical wire that I normally use for this kind of a job. All right, one more on this resistor array. Now that I'm looking at all the wires I gotta do on this side, I actually might have started at the wrong spot here. I probably should have gone down to the lower solder points on the other resistors and pads and stuff below this. It's gonna be kind of hard to get to them now since the wires are in the way, but I'll make it work. All right. And this one goes to 16. Okay, well there's one resistor array done. There's two more resistor arrays and a bunch of other stuff. You know, Matt Clausen, I'm pretty unfamiliar with the PS2 modding scene as well. I've never really worked on PS2s outside of my own personal PS2 and some friends' PS2s, installing mod chips and stuff back whenever I was a teenager. But in modern times, I haven't really worked on PS2s at all, really. So I'm kind of just trying to delve into some different kind of angles of the modding scene that I've never really messed with before, which is where like the Fram mod that I did on the JVC XI, that was another one that I don't really mess with the with the Sega stuff for modding, and this was a good opportunity to do some Sega. That was a good opportunity to do some Sega stuff. This is a good opportunity to do some PS2 stuff. Just trying to broaden my horizons here and try to create solutions to problems that I see in areas of modding that I'm not so like regularly familiar with, you know. Okay, let's see. We need to get a pin. We need to get a wire soldered to this pad here. That pad there needs a wire. And some of those resistors under there need a wire. So I'm going to do this pad here first, and then I'm going to tuck those wires over the other way, and then I'll get to those resistors down there. Yeah, Matt, I'm not the first person to do this this iFlash mod. I know that there are other people who have done the iFlash mod, but there doesn't seem to be a flex cable, like anything for an easy install available for the iFlash. And the iFlash mod to me seems like the most ideal mod that you could do for a slim PS2, because it doesn't have the 128 gigabyte limit that the StarTech SD card adapter that most people use has, because that 128 gig limit is a huge limitation for PS2 because the library is so big and the games are so big. 128 gigs isn't gonna get you close to having a PS2 library on a card. So this seems like a good way to bypass the limit, and I mean, they're available. They're not that expensive. This Iflash Solo was like 35 bucks. So cost-wise, it seems pretty reasonable. And this seems like the best adapter on the market. So if there's a flex cable to make it easy, then that would make it like the ideal choice. I think the reason that it's not done very often is because up to this point you have to like you basically had to sit here and hand wire every one that you do. Kind of like what I'm doing. Although I'm not sure if anybody's used the ZIF version of the iFlash. There's like a version that's meant for a older generation of iPods before even than this one, that uses a little like a mini IDE connector. So it's like a small version of a normal IDE 40-pin connector, or 44-pin like a laptop connector, but it's even smaller than that. And people have manually soldered those because that's a lot easier to do than to solder to a flex cable, you know, to flex cable pads. But that's not what we're doing. What we're trying to achieve here, we're trying to achieve a completely, you know, solder in the flex cable and then you're done kind of deal, where you're not trying to solder to each individual pin or have any wires really at all. Alright, so for the next wire, it's going to be this resistor right here, the one furthest to the right. The right-hand side of that resistor, we need to get that one. Get a wire on that one. I'm going to use my J-tip because it should be able to get us in tighter there. Okay. Throw some flux in there. Yeah, it was definitely a mistake to wire the resistor array first, because this is pretty tight. Okay, let's see. This one goes to pin 22. Pin 22. Oop. Just about soldered it to the wrong spot again. Trying to solder it to 24. All right, so that's that one. So the next one is this right-hand side of the second resistor. All right. So this one needs to go to pin 30. Okay. One more of these resistors. And then I think it's just pads. I think it's just pads the rest of the way on this side of the board. So once again, oh, I bridged those two resistors together. All right, that's all clear. Conquer, you could definitely use magnet wire for sure. I don't like magnet wire that much. I've used it for repairs and stuff. That's typically where I end up using it is when I'm repairing traces and stuff. I don't personally love magnet wire for this kind of stuff because it's kind of a pain to deal with in terms of you know, you gotta get the enamel off of it, and that requires a lot of heat, and sometimes you can overheat magnet wire and strip enamel that you didn't mean to strip, and it's just I prefer jacketed wire for this sort of thing typically, unless there's some special circumstances. But you could definitely do it if that was your preference. There would be nothing wrong, I don't think, with using enameled wire or yeah, enameled magnet wire. Hmm. Well, maybe melting the insulation isn't that great for these tight quarters because this insulation is getting a little sticky when it's melted. So it might be better to strip it in advance. Okay, let's give this a try. Yeah, that'll work better because it's laying more flush. Okay. This wire goes to pin 27. Oh yeah, yeah. No, Conquer, you're totally. It really does. This sort of stuff comes down to personal preference, really. There's not really a wrong way to do this sort of thing unless you know, I don't know, unless you use like unless you try to use like 24 gauge stranded wire or something to do this, and you're probably going to have a bad time. But, you know, as long as everything gets to where it's supposed to go and, you know, is reasonably the correct gauge of wire, I think that you'll be fine. Okay, that's 27 in. Oh, okay. So this pad right here above the resistors, that pad right there, that's going to be the next one we get. All right, this one goes to pin 24. Finally, we get to do pin 24. I jumped the gun on it earlier. Okay, next is going to be this pad right here. That is going to be 29. If you were going to do this, I would probably stay away from this ZIF version and just get the iFlash ATA because it has pins you can solder directly to on the iFlash board. The only reason that I'm doing this is because I'm designing the flex cable. Once I've designed the flex cable, this will be an easy, well, relatively easy mod to install. And the plan for the flex cable is to put it on GitHub so you can get it made yourself, or if you want to buy it from me, of course, I'll sell it as well. Okay, so we got all of the resistor array, we got the 3 individual resistors, we got these 2 pads, we got this pad here. So that leaves looks like that only leaves 2 more pads on this side, and then we're moving over to the other side of the board. And those 2 pads are right here. These 2 pads right here. So we've got kind of a mess of wire on our hands here. I definitely didn't route this in the most efficient order, but that's fine. We're learning here. This is new for all of us here. All right. Go ahead and tin these pads up. I don't like that. There we go. So this one goes to pin 36. 36. All right, one more on this side, and it's gonna be a challenge to get to this one. Let's see if I can move them. Maybe if I move everything out of the way this way. There we go. Should be a little bit easier to get to that. Okay, this last one here goes to pin 35. Well, that's convenient. Okay, that ought to do it for this side. Beautiful. It's not the prettiest work I've ever done, but hey. This is a prototype. It's a test. It's just a test. All right, so on the other side, basically we're soldering to this resistor array here, this resistor array here, this resistor array here, and these 4 pads here. And I think that's all we've got to do here. So let's go ahead and take a look at this. Yeah. Yeah, that should be everything. So we'll start with the bottom 2 of these pads so that I don't have to work over top of them like I did on the other side, because I did everything backwards. I'll just go ahead and pre-tin these pads, get them all nice and fresh. Okay, this goes to 31. And this one goes to 33. All right, and then we'll do the other 2 pads on top. And then we'll move on to the resistor arrays. Okay, so this one goes to 25. Okay, this one goes to 34. All right, it's resistor array time. For these ones, I think I'm going to go over the top of them. So we'll start here. Start here on this one on the left, and we'll go ahead and tin it up. Then I'm just going to come over the top here. Okay. Come over the top here like so. And just tack it in place and then fold it over. So this one needs to go to pin 15. Yes, I said pin 15. Bunch of children around here. Am I right? Kind of feel like I should have done the top first, because it seems like that's going to be mostly going to be on the odd row, which is covered up by the even row here. So it's going to be a pain. Obviously, I did this entire installation backwards. So if you want to try doing this without a flex cable yourself, don't follow my lead. Just do everything I did in reverse. That seems like probably the appropriate strategy. Okay, this one goes to 19. There we go. This new wire is nice, but it is a little bit tricky to deal with whenever it comes to the jacketing, because the jacketing's pretty strong, and when you try to strip it, if you're not careful, you can end up just clipping the end off of the wire. So you have to be kind of particular about how you do it. Can't really. Can't really see super well. I don't think that's a very good connection there. Hmm. I don't know why this one is being so difficult. This is crazy. Let's see. Okay, finally. All right, this one goes to 13. Okay, one more on this array, and then we're off to the next one. Okay, so this one goes to pin 17. All right, well, that's the first array done. Now we'll move on to the second resistor array. Poke, when you are when you say, if you don't want to strip the wiring, it seems better to use UEW, polyurethane cable. Are you saying that polyurethane cable is like melts easier so that you don't have to strip it, you just heat it up? Because if that's the case, then I already have some PVC wire that is, you can just heat it up and it'll kind of strip itself with heat. But the problem with that PVC wire, at least, is that it is so sensitive to heat that when you heat it up, like if you're holding it with your tweezers, it just heating it up and holding it with the tweezers end up melting through the jacket while you're holding them, even though you're soldering, further up the wire. That drives me crazy. So I'm hoping I got this this different wiring, which I'm not even sure what, I think it's PVD jacket, and it is really good about it's got much better resistance to heat as far as just melting on you while you're trying to work with it. So I like that aspect of it, but it does make it more difficult to just do the thermal stripping instead of actually mechanically stripping the wire. So some flux would help. Wow, what the heck is going on here? What the heck is going on here? Why is my flux just like not fluxing? Maybe I didn't get enough solder tinned onto those pads. Okay, this one is going to pin 9. All right. Next one up. Something really weird is happening on this portion of the board. We're going to move over to the microscope temporarily because I can't see what I'm doing well enough at this angle. And we'll see how I fare under the microscope. Oops. Just desoldered one of my desoldered one of my wires here that I had already had in place. Just fix that real quick. Okay. Okay, that worked. All right. So, let's see. That was the second one on the second array, and that is going to be pin 11. 11. For anyone who isn't privy to what we're doing here, we're doing a, this is a test installation of an Iflash Solo SD card adapter that's meant for iPods, but we're going to be we're installing that into this PS2 Slim instead of the typical StarTech SD card adapter that most people use, and that is going to allow us to have more than 128 gigabyte sized SD cards on our PS2 for OPL, for loading hard drive games from OPL. Because the StarTech SD card adapter has a 128 gig limit, and these iPod SD card adapters do not have said limit. So that's the reason that we're doing this. This is not meant to be a finalized install. This is just a test to see if my wiring, my pinout is correct for this. Once I've established that it's correct, I'm going to be designing a flex cable that will make installation very simple. All right, this one goes to pin 5. We're in the home stretch, boys. One more pin on this array, and then one more resistor array to do, and then we're done with the wiring. And then it comes time for the exciting process of seeing if my wiring diagram is correct. Suppose that hinges mostly on whether or not the pinouts that you can find for the 1.8 inch 40 pin ZIF socket that these iFlashes use is correct. I found one online hoping that it's correct. It's the only one I could find. Well, there goes that pad again. I keep grazing it. Okay, let's see. This one goes to 7. Pin 7. Oh, sorry about that. I got it soldered, if you didn't notice. All right. This resistor array is the last one, so we've got 4 more pins to solder, and then we should be able to test. That bridge is in there. There we go. Okay, this goes to pin 6. Okay, this one goes to pin 12. Okay, this one goes to 8. And the last one, at least the last one out of the signal pins that we need. We still have to get power installed. Power and ground. Oh. This one goes to pin 10. All right, that's it for all the signal wiring. So now we need to wire power. The iFlash runs on 3.3 volts, so we can't get power from the normal locations that most of the guides for hard drive installs normally suggest. We need to get it from, let's see, let's see.
Your favorite primetime channels are on YouTube.
Love this kingfisher blue. I'll try not to get blood on it.
Enjoy the latest shows and films.
Get in, loser.
Mod chips. Mod chips are the ones that actually use 3.3 volts typically, so
AMC.
I just need to find a diagram for a V12.
Find your favorite movies and TV on YouTube primetime.
Okay, 3.3 volts. That's going to be, looks like right here. This location right here is where we're going to get 3.3 volts. So for that, we're going to switch over to some stranded 24 gauge wire. Give us a little bit more current carrying capacity for our ground and power. Okay, so this here is going to be the point where we get power from. then let's see. 38 and 39 are the pads that actually have power. So I'm just going to bridge this wire across like so. Get power to 38 and 39. So that's our 3.3 volt supply. Then we also need to get ground. Now ground we can get from anywhere. The ground pads are 4, 21, 23, 26, and 28. I'm not going to actually connect all of these ground pads because the iFlash, I've already verified the iFlash has the ground plane connected internally. So I'm just going to get one of them for the test, and that should be sufficient. One ground should be sufficient for testing purposes. This thing doesn't use a lot of current anyway. I'm gonna go to pin 4. And we'll snag our ground. Let's see. Hold on. Let me grab my multimeter. Okay, ground's going to be over here, so I want to find a closer ground point. So I'm going to poke around. So that's ground, but I don't want to solder there because the screws the screws hold the motherboard heatsink in place go there. Yeah, that's not ground. Oh, wait. Oh, that is ground. That's ground. That's ground. So I think I'm gonna go right here. That's definitely ground. Okay, we'll go there. And I'm just going to use pin 4. All right. Well, we're all wired up, so let's go ahead and get the iFlash plugged in. And we'll do a quick little continuity test to make sure that ground is actually connected where it's supposed to be. And such. So first of all, is ground connected between the PS2 and the iFlash? Yes, it is. Okay. And then ground should be available on 4, which it is obviously because that's where we soldered it first. Then 21. Yep, it's there. Then what was it? 23. 26, 28. So there you go. That's weird. It's not shorted, but it's very low resistance between ground and 3.3 volts. Let me check what it's like if the iFlash is not connected. Oh, now it's not low resistance at all. That's strange. So on the iFlash, let's see. Oh, ground and 3.3 volt are not particularly low resistance. On the actual pins of the iFlash, that's strange. Oh, now it's... Oh. Dude, I don't know. This is fluctuating all over the place. Interesting. So... something weird's going on there. But I tell you what. This is an experiment. This is testing. Let's just YOLO it and give it a try. Why not? I mean, it's not a dead short. It's just a low resistance short. It's like 50 ohms. So, you know, maybe something will heat up and it won't boot, and that'll be all there is to it, and then I'll just have to try to figure out why that is. Okay, I'm gonna put in a free MC boot. Hold on just a second. All right, so we're gonna fire it up in this configuration with the free McBoot memory card. And let's see, I need to put the power switch back in place. I'm a bit skeptical about this, but we will see what happens. Okay, the PS2 didn't explode. The power LED's on, so that's somewhat promising. And it powered on, it didn't explode. We've got free McBoot. Oops. See what happens if we load OPL. Interesting. OPL is not loading. Let's try going back into ULaunch. And go to the hard drive tool. Interesting. So it seems like it's just getting hung actually trying to read the hard drive information. Okay, I'm gonna pull the plug here for a minute and we will try a few things here. Try reseating the SD card. Could also try a different adapter too. I don't know if that's potentially a problem. Oh, that's what it was. Look at it go. Look at it go. Okay. It seems to be reading it. Let's pull the plug here for a second. I'm going to pop the top shield back on so that there's a heat sink on here at least. And then we'll go back into OPL, see if we can load a game. Where the heck did I put the top shield? Oh, there it is. Okay, let's see. I would assume that normally you probably bend these up, these little shield fingers up to protect the hard drive wiring. Ah, heck, we'll go ahead and plug in the fan too, for good measure. Now, I don't think I'm going to be able to reinstall the bottom plate with this mod in place, but I'm going to go ahead and pop these screws in to hold the heatsink down. I think the plan is probably going to be the bottom shield plate will be removed for this mod, and then you'll just install some washers and these screws to hold the heatsink in place instead of having a bottom shield, because ultimately, once the flex cable is designed, the iFlash is going to sit down here. So we want to have that inside of the shell, and I don't think there's any way it's going to fit clearance-wise vertically with the shielding on the bottom. So, all right, let's plug her back in. Try to load OPL. See if we can't get a game running here. Oh. Oops. Don't know how we ended up in OPL, or, okay. No, we're good. Alright, let's see. We need OPL. Okay, well, there's some games. Let's try booting one of them. Trying to think if there's any games that, I've got a PS1 controller here, so I don't know if this is gonna work with any of these games. Let's see, what's a good Kingdom Hearts, baby. That's my childhood right there. And I'm getting nothing. I don't know, there might be a compatibility setting that's wrong on Kingdom Hearts. Wonder if GSM is turned on. A lot of times GSM screws up these a lot of these PS2 games. Let's go check. I have a 512 gig drive in here right now, so we know for sure that this puts us over the 128 gig limit because it's addressing the whole drive. The main issue is just whether or not games actually launch. Let's see. Don't want to do. Let's try Devil May Cry, but let's turn off GSM. Oh, no, it is off. Well, I wonder why Kingdom Hearts didn't load. Does it have unique compatibility settings that need to be addressed? Yeah, this doesn't appear to be loading either. Well, this is disappointing. I mean, it's reading the drive. So it's kind of weird that it's not actually loading games. Is there a quirk to this that I don't know? Does anybody know? If there's like a quirk to how OPL works on V12 PS2s with a mod. With a hard drive mod. Seems like configurations are working. Let's try making a VMC. Oh, wait. Oh, wait. Huh. So it's like freezing? Is it just freezing at startup? That's why we're getting a blank screen on the others, because they don't get this far, maybe? Maybe the God of War is unique in that the Sony computer entertainment screen pops up like instantly whenever it's loaded versus not instantly. Huh. Hmm. Let's see. We'll shut this back down. Try removing the iFlash and then reinstalling it again. Just to see if maybe it's just not seated exactly right on the flex cable. This flex cable is not really the right thickness. It's a little too thick. Try removing the backing and just put the bare flex cable in to the iFlash and see if it inserts deeper and gets better contact in there, because this is barely grabbing the edge of it. Where's my pliers? These will probably work better. This is probably not going to work, but hey, I'm going to try it. And we'll see. Okay. Well, that mangled the flex horribly, as I kind of expected it to. So I don't know. I don't know what my chances of getting this back in there are gonna be, but we're gonna give it a shot. We'll give it a shot. Oh no, that's not gonna work. It's too mangled. Let's just pop this loose and pop this flex cable out and then swap it for another one. I have a spare. I'll have to desolder the 3.3 volt here to do this, but all right, let me go grab another flex cable and we'll give this another try. Okay, I'm back. New flex cable. And I was just thinking on the way to get this flex cable, I was thinking maybe we might have a SD card compatibility issue too. This is a PNY SD card. And I don't know how... These seem to be kind of low grade SD cards. So it could be an issue with this particular SD card not liking the iFlash, or the iFlash not liking the SD card or something. So I want to keep that open as a possibility. All right, let's give this another shot here. Let's try a game. Hmm. Well, so I'm left with a few possibilities on what the issue could be. It could be SD card compatibility. When the iFlash actually loads the game off of it, it could be freezing because it just doesn't like this SD card. It could be wiring. The wiring may be a little bit too loose here, and it's picking up interference that it's not supposed to or something. This isn't shielded in any way. There's no grounding wires running parallel like you would have on an IDE cable. Obviously, the drive is detected. The games are read off of it, so it is able to read the drive. So as far as that's concerned, that seems good. So I'm starting to think that maybe it might be worthwhile to just go ahead and make the flex and see what happens. Because there are other flexes out there that do this exact thing, and they work. So it might just be an issue of loose wiring creating problems here. I don't know. We'll try a different SD card as well. See what happens. But yeah, I think we're stuck as far as this SD card is concerned. Let me think here. Let's see. Let's try formatting this SD card with the hard drive manager and see what happens if we try to do that. I'm wondering if we get any kind of error with the formatting process, or if it goes through and formats just fine. Obviously it's not working right now, so formatting this card doesn't hurt anything, and I can always just load games back onto it later. So we'll go miscellaneous, HDD manager. Come on. Load those games. Man, it's loading so slow. One thing I've noticed about these PNY cards is they get really hot while you're using them. Like, frighteningly hot. I'm not saying that necessarily has anything to do with it, but huh. I wonder if having a completely full hard drive is a problem. Oops. Oh no. Are we gonna have to wait for it to load all the games again? No way. Oh man, what a screw up. Oh, I don't even want to do this. Does anybody know? Is a full hard drive a problem for OPL? Does it have issues when the hard drive is completely full? My main PS2 has a 1 terabyte hard drive in it, and I've got like, I don't know, like 600 gigs of games on there. So I'm nowhere near full. I don't know that I've ever really tried to push a drive to full on OPL. Definitely takes its sweet time to load the HDD manager. What did I do wrong here? How did I end up out of the HDD manager? I swear. I'm pretty sure. Oh, you know what? I hit the wrong button. That's why. My bad. All right, well, in about a half hour, whenever it's done loading the games, we'll try to format the drive and then try to load like 1 or 2 games back onto it and see what happens. Okay, let's try this again, but not screw it up this time. Okay, it formatted just fine. We'll shut it down. Let me run over to the computer and pop a couple of games on here. I'll be back in like a minute. 2 minutes.
Would you build a website for a major brand with more than 200 million users using Wix? Well, we did.
Okay, I've returned. I have returned. Sorry about that. Took a bit of time because it took longer to transfer the games than I thought it was going to. Okay, so I transferred a few games onto here. Let's see what happens. I've only got 4 games on here right now. So we'll see if maybe the hard drive being completely full, well, the SD card being completely full, we'll see if maybe that had some effect on it. Because according to the HDD manager, that was completely full, 0 megabytes free. And I could see how that might potentially cause a problem, maybe. I don't know. Speculation on my part, but we'll try launching Devil May Cry. So it looks like we're still getting stuck here. So, starting to feel like SD card compatibility could be our culprit. Hmm. Try turning on mode 1 accurate read, see if that does anything for us. Doesn't seem like it. Seems like we're still freezing. Seems like we're still freezing. Okay. I'm gonna go get a different SD card and load like 1 game onto it, and then we'll give that a shot. All right. Never loaded, eh? Okay, let's give this other SD card a shot. This SD card is a small one. It's a 32 gig card, so it doesn't really demonstrate the high capacity aspect of the whole mod here, but it's the only it's one of the only SD cards I have laying around that I can just spare to format right now. And at this point, I'm just trying to figure out if I can get anything to boot. This is a SanDisk card. Yeah, it looks like nothing. Like no dice on the SanDisk card as well. So that puts the iFlash squarely into question. It's weird. It's weird. It seems like this should work. I'm just not sure what the holdup is. Well, I guess I'm gonna call it for the night, and I'll do some more troubleshooting with this later on and try to figure out what I've got wrong here. I suppose it could be a wiring issue, although it seems like if there was an issue with the wiring being incorrect, that the drive wouldn't be able to load, you wouldn't be able to load any data off of it at all. So it is weird that you can access the drive, you can see what's on there, but the games don't actually load. So that kind of leaves me with either there's an issue with interference with the way that the wiring is done here. Maybe the wire runs are too long or too poorly managed for this. Maybe the extra flex cable on top of the adapter board on top of the wire runs is too much distance for it to go without any shielding or anything. I don't know. I don't know. But I'll tinker with it a little bit off stream and see what happens. I have a feeling it's a signal, some sort of a signal issue, some sort of a signaling timing issue that has to do with the fact that I'm running the wires to an adapter board, to a flex cable, to the iFlash. So I might end up just proceeding with the design of the flex cable and prototyping that to see what happens. Even if I can't get it working in this kind of test configuration, I might just go ahead and get a flex made. And see if it works with the flex where it's actually the correct length and you don't have all this excess wiring involved. Yeah, I'll think about that. One more thing I want to try before I call it for the night. I want to go back through the adapter board and just double check my wiring, like the quality of the connections. So I'm going to go hit each one of these connections with some solder again to try to make sure that we're getting a solid connection to the wiring. And then we'll see if that improves the situation at all. So we'll go in here and just resolder each one of these wires. Lost that one. Okay. Refloat all of those connections to the adapter board. See if that improves our situation at all. Alex, hey, what's up? Not looking super promising. Looks like we're frozen again. Yeah. Oh man. Well, I'm tired and this is not working. So Alex, the Jamizer prototypes they're in the They're in the process. They're being made right now. As soon as I get them and I test them and I make sure that the new design doesn't have any issues, I will have them on my website. So you don't have to worry about that. And they're going to be easy to get a hold of now because the redesign helps me to get them at least partially assembled by the board house that makes them, that makes the boards for me. So it won't be as much manual assembly for me on this new revision. And that'll make it way easier for me to keep these in stock, because the old ones I had to hand assemble literally every component on there. So it was very difficult to stock them because I just didn't have the time to do all of that. But this is going to fix that problem. Hey Alex, what stick are you trying to use with the PlayStation adapter? Which model of arcade stick is it? Still freezing. Let's see. Okay, Alex, yeah, some arcade sticks don't work on my adapters because the PlayStation adapter library that I use for it has some compatibility issues. Hori arcade sticks, I know for sure don't work, at least not in the current configuration of the code. I have been looking into reworking my code to try to improve compatibility, but that's a big project because I had to actually do analysis on the PlayStation controller protocol and would have to write my own new version of the PlayStation controller library, which would be pretty time consuming for me. And I do have a lot of other projects going on right now, so I'm not sure when that will be that I can address that issue. But if it's not a Hori arcade stick, if it's like a Namco stick or a Namco stick, I'm sure there's some other ones that are not Hori. I just can't think of them right now. It may work just fine. I know the Namco stick works. There may be some others as well, but I can't say 100% for sure. Just double checking for loose wires or shorts or anything like that. Let's see. See if there's any shorts over here. That's not a short. No short there. Let me think about something here. Let's go take a look at my schematic. Let me go take a look at my schematic. Let's see. Master slave select. Dev ADR. Well, I wonder. What would happen. So one of these pins in my pinout is not connected to anything. Well, several of them are, but that's because they're not important. But one of them that I was curious about is this dev ADR. That's the master slave select pin for a 1.8 inch hard drive, which is what this is. I'm curious if I drive this to ground. I wonder if there's something going on with this pin being floating. Maybe if I drive this pin to ground, it will help. I don't know which way is which, to be honest with you, so I don't know if driving it to ground makes sense or if driving it high to 3.3 would make more sense, but I feel like driving it to ground is the safer option to test and see if there's any changes in behavior. Because basically, I would imagine if this pin is important, that driving it to ground would either, if it helps the situation, it would either help the situation, fix it, make it work better. Or if it hurts the situation, I would imagine it would stop the drive in its tracks. So it would, like, I would assume driving it low would potentially just stop it from even being detected. Depending on how the PlayStation handles this, I don't know. Or it may have no effect at all. I don't know at this point. I'm curious. Okay, so I've connected pin 40, which is dev ADR, which is the master slave select on a 1.8 inch hard drive. I've driven that to ground. We'll see if that does anything. See if it changes anything. I'm not confident, but hey, we're in experimentation phase here. We don't really know what's going on. Well, the hard drive's still detected, so that's something. But looks like we're frozen again. Oh, man. All right, well, that's it for me for tonight. I'll troubleshoot this some more later on and try to figure it out. I'll try maybe a different version of FreeMC Boot, maybe a different version of OPL. I'll mess with it some more and hopefully I can get it working. But anyway, thanks for tuning in, everybody who did. This was not, I didn't really expect to have success per se. This was just an experiment to see what would happen if we tried to wire this up. We have partial success. I mean, it detects the drive. It just doesn't load games. So I have to do some more troubleshooting to try to figure out why that part of it's not working. But at least on the level of, can the iFlash communicate with the PS2? At least that part is working. So I'd say that's a good step in the right direction. So anyway, with that, we'll just call it for the night, and I'll follow up later once I figure out what's wrong with it. Probably do another video on it. And if I can sort it out, then we'll go into flex cable design and try to produce a flex cable for this install. But anyway, I'll catch you guys later.